Santham Academy. Welcome to Digital Kaksha. To get updates on new videos, click the subscribe button and the bell icon.
Hello students, today we will study the chapter number 12 of NCERT, Electricity. Let us first know about the meaning of the term electricity. So, this electricity, it is a form of energy. Now, this form of energy in very convenient form we are using at our homes, in schools and various other places. Now, in order to understand many concepts in this chapter, let us first of all acquaint ourselves with certain terminologies. Students, there are several terms, there are several physical quantities which we must aware of to go to the higher level of the topics in this chapter. So, first of all, we will start studying this chapter from the terms about which you have certain idea from your lower classes in the subject science. So, let us discuss first of all the meaning of the term electric circuit. Electric circuit is a closed and the continuous path in which the current flows. So, this electric circuit is comprising of several components like the cell, the battery, the key, the connecting wires, the resistors, the bulb, etc. A list of components, it is shown for you on the screen. You can see the symbols and understand that what way these components are to be drawn. We will be using these components and their symbols in various circuit diagrams in this chapter. Okay, let us come back. So, we were talking about the electric circuit. After studying the meaning of the term electric circuit, let us now discuss about the term electric current. Electric current, it is a physical quantity which is defined as the rate of flow of charge. The formula for the electric current is given as I is equal to Q upon T, where I is the standard representation for the current, Q is the representation for the charge and T is the representation for the time. The physical quantity electric current has got its SI unit ampere, which is denoted by capital A. The device which is used to measure the electric current in a circuit is called as ammeter, and this ammeter is denoted by the symbol capital A, which is encircled with the positive and the negative sign. In order to understand the definition of the SI unit of current, that is 1 ampere, in this formula I will substitute Q to be equal to 1 coulomb and T to be equal to 1 second. That means 1 ampere of current is defined as the flow of 1 coulomb of charge in any circuit in 1 second. After this, let us come to the next physical quantity, that is charge. So, charge is the physical quantity possessed by the objects due to which they are attracted to or repelled from each other. The like charges repel each other and the unlike charges attract each other. The example for the positively charged particle is proton, and the example for the negatively charged particle is electron. When charge is a physical quantity, certainly it has its SI unit as well. So, the SI unit for the charge is coulomb which is denoted by capital C. When we have to calculate the charge possessed by any of the object, we have the formula capital Q is equal to N into E, where Q is representing the charge of that object, N here is representing the number of electrons, and E is the charge of one electron, which is equal to 1.6 into 10 to the power minus 19 coulomb. In order to understand the definition for the SI unit of charge, or in order to understand the definition of 1 coulomb of charge, we have to use this formula, where when we will substitute Q to be equal to 1 coulomb, the N will be given as Q upon E, and this value of N, which is the number of electrons, it comes out to be 6.25 into 10 to the power 18. It means 1 coulomb of charge is defined as the charge possessed by 6.25 into 10 to the power 18 number of electrons. Let us now know about the next term, potential difference. Potential difference, it is a physical quantity which is denoted by capital V, and this physical quantity is defined as the work done to carry a charge of unit value from one point to another point. Formula of the potential difference is given as V is equal to W upon Q. The SI unit for the potential difference is volt, and this volt is also represented by capital V according to the standard notation. 1 volt is defined as that potential difference which is obtained when 1 joule of work is done for the movement of 1 coulomb of charge between the 2 points. The device which is used to calculate the potential difference in any of the circuit is called as voltmeter, and the symbol of voltmeter is drawn as capital V, encircling it with the positive and negative signs. Now, where is this potential difference existing in the circuit diagram? In order to understand that, let us have a look on this circuit diagram. In this circuit diagram, it is representing a battery. Battery means this is the positive terminal and this is the negative terminal. The longer side is positive and the shorter side is negative. So when we are talking about the term potential difference, this potential difference is existing between these positive and the negative terminals of the battery. When the key is connected in this circuit, that means when it is a closed circuit, at that time the electric current has got the direction from the positive terminal of the battery to the negative terminal. We have talked about the two devices so far, that is emitter, which is connected in this circuit, and this connection is called as the series connection. We have to notice that the like terminals of the emitter and the battery should always be connected. Just now we have talked about the device voltmeter to measure the potential difference. This voltmeter is also connected here in the circuit. This is the representation of a fixed resistor and it is denoted by capital R. This symbol is the notation of the variable resistor. Let us now study about the next topic, that is Ohm's law. Ohm, he was a scientist who has given the statement of this law as the current flowing through a metallic wire is directly proportional to the potential difference applied across the ends of the wire when the temperature remains constant. This statement can be written in the mathematical form as I is directly proportional to V, or this statement can also be written as V is directly proportional to I when these two quantities, that is potential difference and the current, they are directly proportional to each other. On the removal of this proportionality sign, here there comes a constant, and this constant is R. This R, it is called as the resistance. The SI unit for this physical quantity resistance is ohms. So, this R, which is called as the resistance, and the SI unit for this resistance is ohms, for which we are using the symbol omega. So, resistance, it is the property of the metallic wire to resist the flow of charges in it. Here in this formula, this R, it is constant when the temperature is constant. The graphical representation for the direct proportionality of the potential difference and the current can be shown in the graph in this manner. When we are plotting the graph with the physical quantity current on x-axis and the quantity potential difference, which is denoted by V on y-axis, when the graph will be plotted, it will come out to be a straight line, and this graph, it is called as the VI graph. So, the straight line in this graph is giving us the idea for the constant value of the resistance R. The SI unit, as we have discussed, for the resistance is ohms. So, 1 ohm is defined as the resistance of that wire for which the potential difference which is applied across its ends is 1 volt and the current flowing through that wire is 1 ampere. The formula for the resistance can be given as V upon I from this equation. From this formula, we can say that the current and the resistance, these two quantities are inversely proportional. The current flowing in the circuit is inversely proportional to the resistance. Let us discuss about the topic factors affecting resistance of a conductor. In this diagram, L is the length of a metallic wire or a conducting wire, and A is representing its cross-sectional area. For this given wire, the resistance will be depending upon the two factors. The resistance, which is denoted as R, is directly proportional to the length of the wire and is inversely proportional to the area of cross section, that is A. On combining these two, I can write it as R is proportional to L upon A. When I will remove this proportionality sign, here I will be getting equal to sign with a constant. The constant which is obtained here, that constant is denoted by the letter rho and is called as the resistivity. Here this rho, it is called as the resistivity. This resistivity, it is the material property. For the different conducting materials, the value of the resistivity is different. Here, the formula for the resistivity can be written as Ra upon L in order to know its unit. We know that the unit for the resistance is ohms, for area it is meter square, and for length it is meter. Ultimately, the SI unit for resistivity, it is obtained as ohm meter. In this formula, when I will substitute L to be equal to 1 meter and A to be equal to 1 meter square, I will get the resistivity to be equal to the resistance. This relation is allowing me to get the definition of the physical quantity resistivity. So, resistivity is defined as the resistance of a wire of unit length and unit cross-sectional area. When we are talking about the conductors, there are two categories. One, it is alloys, and the another one, it is metals. Since we have discussed just now that resistivity, it is a material property, so there are the different values for the different conductors for their resistivity. The substances with less value of resistivity are said to be the good conductors, and the substances with the high value of the resistivity are said to be the poor conductors of electricity. When we are comparing the resistivity values of the two categories of the conductors, that is alloys and metals, from their values, the resistivity of alloys is greater than the resistivity of the metals. Let us see now the practical application for the formula of resistance R is equal to rho L upon A with the help of this question. The question is given as the resistance of a wire is R. What will be its new resistance when it is, the first part is stretched to double its length and the second part is it is doubled on it. So, according to the given condition, in part A, the new length is given as L dash, which is equal to 2L. Now, when a wire is stretched as it is given in the first case, or when it is doubled on itself in the second case, in both the cases, the physical quantity volume of the wire will remain same. That is why when the new length will be the double of its initial length, its cross-sectional area A dash will be equal to half of its value. Now, after understanding the given quantities, let us see how the values are to be substituted in the actual formula. The formula for R is given as rho L upon A and R dash will be written as rho L dash upon A dash. The term resistivity will remain constant since it is a material property, so its value will not be depending upon the dimensions of the wire. After substitution of the values, here rho into 2L upon A by 2. After solving, the value of R dash will be obtained as 4 rho L upon A, which can be written as equal to 4R. So, in this case, the new resistance of the wire has become 4 times of its actual value. Let us now solve the part B, where it is given that the wire is doubled on it. In this condition, the length of the wire will be the half of its initial length. Again here the volume will remain constant, that is why the cross-sectional area will be double of its initial value. Applying the same formula here, that is R is equal to rho L upon A and R dash is equal to rho L dash upon A dash. Let us substitute these values here. So, R dash will be equal to rho as it is, in place of L dash, L by 2 upon 2A. When I will solve it further, I will get it as 1 upon 4 rho L upon A. This rho L upon A from this relation can be written as R. So, this can be written as R by 4. It means in this case the resistance of the wire has become 1/4 of its initial value. So, with these questions, I hope that you have understood the concepts which are explained in this video. Thank you all for watching.
Thanks for watching. If you like this video, make sure to like, share and subscribe for more.